Creating a simple PLC program using Siemens TIA. Simple bit logic operations. Normally open input and normally open output. These are the two ladder logic symbols we will be using. Normally open input and a normally open output. This is the main programming screen of the Siemens TIA package. You can see a blank ladder logic program in the centre. Over to the right, we have drop-down lists of instructions. Commonly used instructions are displayed in favourites. Open up basic instructions. Click and drag a normally open contact over to the left of the first ladder. This will act as an input to our simple circuit. By clicking on the red question marks, we can specify which PLC input we are going to use. Here we type I0.0. This means we are using the first input on the PLC. I0.1 would be the second, I0.2 would be the third, and so on. We can then click and drag a normally open output to the right-hand side of the ladder, as shown. Click on the red question marks and enter Q0.0. This means we want the first digital output to be driven by this circuit. Q0.1 would be the second output, Q0.2 would be the third, and so on. We can now download this simple program to the PLC. These buttons allow us to start and stop the PLC. The PLC must be stopped before a program is sent to it. Stop the program and follow the prompts. This button downloads the program to the PLC. Click this icon and download. Follow the prompts, then click the Start button. After a short pause, the PLC will signal it is in run mode. We can enter monitoring mode on TIA by using this icon. This will show the inputs and outputs changing in real time. Without switching input 0, you can see that the left-hand part of the rung lights up green. This means that the logic signal, or electrical current, cannot pass the switch. If we now toggle the switch on input 0, logic or current can now pass the switch. And because the output is a normally open output, if it sees a logical 1, or the presence of current on its input, it will switch on. We can toggle the input switch to see the effects in real time. Look at the inputs and outputs and you will see that output 0 will follow the state of input 0. Look at the inputs and outputs on the front of the PLC and you will see that output 0 will follow the state of input 0. Look at the inputs and outputs on the front of the PLC and you will see that input 0 will follow the state of input 0. We can toggle the first input and watch the behaviour of the output. Here the input 0 is off and output 0 is also off. Input 0 off minus output 0 off. 1.2 normally closed inputs. Here we introduce a new ladder logic symbol. This is a normally closed input. It is analogous to a push-to-break switch. In other words, it will activate with a logical 0 or the absence of current on its input. If a logical 1 or current is applied to its input, it will switch off. This time we will look at the effect of changing the input from normally open to normally closed. A normally closed contact effectively reverses the input logic, the switch position. So if the switch is on, logical 1, the normally closed contact is off, logical 0. Create the ladder program shown. If we run this program in monitoring mode with input 0 off, we immediately see that output 0 will activate. This is because the normally closed input is active when the attached switch is off. You can see this by looking at the LEDs on the front panel. Now try toggling the switch on input 0. Input on, output off. Input off, output on. The NOT function. Here we introduce a new ladder logic symbol. This is a NOT function. It reverses the logic on its input, turning a logical 1 into a 0 and vice versa. A NOT gate also has the effect of reversing logic. It would change an input of 0 to an output of 1 and vice versa. Input 0 on, output 0 off. Input 0 off, output 0 on. Set and reset. On the program we have looked at so far, the outputs immediately change when the input changes. Often we don't want this to happen. We might want an output to switch on and stay on until something else switches it off. The program here demonstrates how to do this with the set and reset commands. Turning switch 0 on will set output 0 to on. If we then turn input 0 off, output 0 will stay on. On the second rung of the ladder, switch 1 is connected to a reset command, which also operates output 0. The reset command is the opposite of set, in that it will turn an output off. In short, this program will allow the output to be turned on by switch 0 and off by switch 1. Timer function, TP. In the timer operations section of the instructions, you will find 4 timer functions: TP, TON, TOF, and TONR, TONR. Here we see the TP function. TP stands for timed pulse. TP produces a timed pulse on its output Q for a defined period of time. TP has 2 inputs and 2 outputs. When logic input in goes on, the timer starts and output Q immediately switches on, logical 1. The timer runs for the time stored in PT, 3 seconds shown here. Once the timer reaches the value in PT, Q switches off. ET stands for elapsed time. It can be read and used to trigger other events during the pulse time. The timer runs for the time stored in PT, 3 seconds shown here. Once the timer reaches the value in PT, Q switches off. ET stands for elapsed time. It can be used to trigger other events during the pulse. For instance, switch an output after 1 second, a different output after 2 seconds, and so on. Timer function ton. The ton timer function can be used to delay an output switching on. In the example here, when input in switches on, the timer starts running. Once the timer has run for the time stored in PT, here it is set to 5 seconds, the output cue is set to on, and it remains on until input in is switched off. Again, ET can be used to measure the elapsed time to trigger other events during the delay. Timer function TOF. The TOF timer function operates in reverse to ton. TOF can be used to delay an output switching off, for example an extractor fan in a bathroom. When in is switched off, the timer starts. Once the timer reaches the time stored in PT, here set to 5 seconds, the output cue is switched off. Timer function TONR, T-O-N-R. The TONR timer has some important differences. Its timer only runs when the input in is on. If in is switched off during timing, the timer is paused. In effect, it records the total time that input in is on. The other timers, TP, TON and TOF, disregard changes to in once triggered. In addition, it has a reset input R, which resets the timer when triggered. Note that the timer can be reset even during timing. Here, the TONR timer is set to time for 4 seconds. After 4 seconds of input in being on, output Q is triggered. Reset is triggered here by a switch on input 2. Counter function CTU. Open up the counter operations list in basic instructions. You will see 3 counter functions, CTU, CTD and CTUD. Here is an example of the use of CTU. CTU stands for count up. In operation, CTU counts the number of times input CU is switched on. Once the counter reaches the value in PV, program value, output Q is switched on. To reset the counter back to 0, input R must be activated. Output CV can be used to read the current count value to trigger other events at certain values. Counter function CDT. CDT, or countdown, operates in reverse, but with some important differences. Note that CDT also has an input labelled LD. To start the counter, LD must be activated to load the initial count value stored in PV into the counter. Once this has happened, the counter then decrements or counts down to 0. Once 0 is reached, output Q is switched on. Note again that it will continue counting below 0 until LD is again triggered to reset back to the starting value. Here the starting value is 10, stored in PV. Counter function CDUD. The final counter function CTUD, or count up and down, it has 2 counting inputs. When input CU is triggered, it increases the count value CV by 1. When input CD is triggered, it reduces or decrements the value in CV by 1. Input R resets the counter. Input LD stands for load data. Triggering this input loads CV with the value in PV. PV is the programmed value. It can be used to set an upper threshold to the counter, above which output QU is triggered. Output QU is triggered if the count value in CV exceeds the value in PV. Output QD is triggered if output CV goes below 0. CV is the current count value and can be read and used to trigger other events.